Next is question number 66, in which we have to find the value of the integral x cube plus x into x raised to the power minus 5 plus 3 times x raised to the power minus 7 whole raised to the power 1 by 8 into dx. Now the given integral is, now here if I take x common, we will get x square plus 1, and let us provide that x in the second bracket. So putting it inside x raised to the power 8, we will get x cube plus 3x whole raised to the power 1 by 8 into dx. Now here if we see carefully that if I take x cube plus 3x equal to t, then differentiating it, we will get 3x square plus 3 into dx is equal to dt. That is the value of x square plus 1 into dx, it will be written as dt upon 3. So the given integral becomes integral x square plus 1 into dx can be written as dt upon 3, and the value of x cube plus 3x is t. So this is t raised to the power 1 by 8. So this is equal to, taking 1 by 3 common, integral of t raised to the power 1 by 8 is t raised to the power 9 by 8 upon 9, and in the numerator we have 8. So this is equal to 8 upon 27 into, putting back the value of t, we have x cube plus 3x raised to the power 9 by 8 plus constant. So from the given options it can be seen that option number 4 is the correct answer. Next is question number 67, which says that a point on the line x plus 3 upon 2 is equal to y plus 1 upon 1 is equal to z minus 1 upon 3, whose x, y, z coordinates are integers at a distance of root 17 units from the point 2, 1, 3 lies on the line. Now here the equation of the line that is given is x plus 3 upon 2 is equal to y plus 1 upon 1 is equal to z minus 1 upon 3. So let us assume it equal to lambda, so that a point on this line can be assumed as 2 lambda minus 3 lambda minus 1 3 lambda plus 1. This is a general point on this line. So it have been given that its distance from the point 2, 1, 3 is root 17. So by distance formula we can write root 17 equal to under root of 2 lambda minus 3 minus 2, that is 2 lambda minus 5 whole square, plus lambda minus 1 minus 1 whole square, that is lambda minus 2 whole square, plus 3 lambda plus 1 minus 3 whole square, that is 3 lambda minus 2 whole square. So this is what have been given to us. So squaring on both sides, we will get 17 equal to 4 lambda square plus 25 minus 20 lambda plus lambda square plus 4 minus 4 lambda plus 9 lambda square plus 4 minus 12 lambda. So this is further equal to 4 lambda square plus 9 lambda square, that will give me 14 lambda square, plus with lambda we get minus 20 minus 4, that is minus 24 minus 12, that is minus 36, and constant term is 25 plus 4, that is 29, plus 4, that is 33 minus 17, that is 16 equal to 0. Cancelling it with 2, we will get 7 lambda square minus 18 lambda plus 8 equal to 0. Making its factors, lambda minus 2 into 7 lambda minus 4 is equal to 0. So from here we get that the value of lambda is either equal to 2 or 4 by 7. So putting it back in 1, we will get the points as, putting lambda equal to 2, we have 4 minus 3, that is 1, 2 minus 1, that is 1, again 7, or the other point will be 8 by 7 minus 3, 4 by 7 minus 1, that is minus 3 by 7, and 3 lambda, that is 12 by 7 plus 1, that is 19 by 7. So let us see which of the point is lying on the options given, right? Now let us firstly talk about first point, that is 117. So we can see that from the given options, if I put 117 in third option, then it gets satisfied. So we can say that option number 3 is the correct answer, because this line is satisfying the point 117. Next is question number 68, a question from definite integral. So let us solve it. It have been given that if integral from minus 1 to root 2 minus 1 dx upon x square plus 2x plus 3 whole square is equal to under root 2 pi upon m plus root 2 upon n, where m and n are integers, then m minus n equals. Now here we can write it as integral dx upon, making its perfect square, we can write it as x plus 1 whole square plus 2 whole square, and the integral is from minus 1 to root 2 minus 1. Now here we know that to solve such type of integral, we can put x plus 1 whole square equal to 2 tan square theta. Now why have we done this substitution? Because if I put x plus 1 whole square equal to 2 tan square theta, then in the denominator if I take 2 common, then 1 plus tan square theta can be written as secant square theta, and its derivative will also be of that form, so some terms will get cancelled, right? So let us see what happens. Now here its differentiation gives us 2 into x plus 1 into dx is equal to 4 into tan theta into secant square theta into d theta. Now this can be written equal to integral. Now as we have done the substitution, so limits will also get changed. So it will go from 0 to, putting x equal to root 2 minus 1, on the left hand side we will get 2. So tan square theta is equal to 1, that gives me theta equal to pi by 4. So dx can be written as 4 into tan theta into secant square theta into d theta upon 2 into x plus 1, that is x plus 1 is root 2 into tan theta, although we will get here mod of tan theta, but the limit is going from 0 to pi by 4, so I am directly writing mod of tan theta as tan theta. And also in the denominator we have 2 tan square theta plus 2 whole square. So this is equal to integral from 0 to pi by 4, 4 into, cancelling tan theta on both sides, we will get 4 into secant square theta into d theta upon 2 root 2, taking 2 common, we will get 4 times 1 plus tan square theta, that is secant square theta whole square, that is secant 4 theta. Now here also cancelling some terms, we will get secant square theta, here we will get 2. So this is equal to integral from 0 to pi by 4 d theta upon 2 root 2, 1 upon secant square theta can be written as cos square theta. Now we know a formula that cos 2 theta is equal to 2 into cos square theta minus 1. So making use of that here, let us multiply 2 in the numerator and denominator. So this is equal to 1 upon 4 root 2 integral from 0 to pi by 4. 2 into cos square theta can be written as 1 plus cos 2 theta into d theta. So this is equal to 1 upon 4 root 2 into integral of d theta, that is theta, plus integral of cos 2 theta will give me sin 2 theta upon 2, and the limit is from 0 to pi by 4. So this will be equal to 1 upon 4 root 2 into pi by 4 plus sin pi by 2, that is 1 upon 2, that is plus half, and when I put 0, so we'll get 0. So this is equal to, multiplying by root 2 in the numerator and denominator, we will get root 2 upon 8, right? So multiplying 8 inside, we will get pi upon 32 plus 1 upon 16. Now comparing with the terms given in the question, we can see that the value of m is equal to 32 and the value of n is equal to 16. So the value of m minus n will be equal to 16. So from the given options, option number 2 is the correct answer. Question number 69, which says that let a, b, c, d be non-zero distinct digits. Number of divisors of number of 4-digit number a, b, c, d such that b plus d is odd is. Now here, to get the value of b plus d as odd, we will have two cases here, right? In case 1, let us assume that b is even and d is odd, right? And in case 2, we will assume that b is odd and d is even. These are the only two cases through which we can get b plus d as an odd number. Now we have the odd digits as 1, 3, 5, 7 and 9, and we have even digits as 2, 4, 6 and 8, because the numbers are non-zero distinct digits, right? So we will not take 0 here. Now firstly select b here from any 4 numbers, right? In 4C1 ways I have selected the digit b, and similarly I will now select an odd number for d in 5C1 ways. Now 7 digits have been left from which we can choose any 2 numbers for a and c. So that can be done in 7 into 6 ways. Now similarly for case 2, let us select an odd number for b in 5C1 ways, and we can select a number for d in 4C1 ways, and for a and c the numbers can be selected in 7 into 6 ways. So we can find that total number of 4-digit numbers will be equal to 4 into 5 into 7 into 6 into 2. That is equal to 2 raised to the power 4 into 3 into 5 into 7. So these are the total number of 4-digit numbers. Now from here we have to find its number of divisors. Now we know the method of finding the number of divisors, 2 raised to the power 4. So we will write it as 5 into 1 plus 1, that is 2, 1 plus 1, that is 2, again 2. So this is equal to 10 into 4, that is 40. So the number of divisors are 40. So we can say that the correct answer is option number 4. Now next is question number 70, which says that if fx is equal to fractional part of x minus 1 and gx is equal to maximum of x square modulus of x and fx, then area enclosed by y equal to gx, x-axis and the lines x equal to plus minus 2 is. Now here we have to find the graph of the three functions. Let us say this is 1, 2. This is minus 1 and this is minus 2. Let us firstly make the graph of x square and mod x. Now mod x is x for x greater than 0 and it is equal to minus x for x less than 0. Now we can see that x square and x have 2 points of intersection, that is x equal to 0 and x equal to 1. So this is the graph of mod x. This is the graph of y equal to x square, and they both are intersecting here at 1, 1 and here at minus 1, 1. Now the graph of fractional part of x minus 1, let's make it separately. We know that the graph of fractional part of x is like this, right? So the graph of fractional part of x minus 1 will be shifted 1 units downwards. So its graph would be something like this. Right? Now from these three graphs we have to find the maximum of these. Now we have to find gx. So that will be equal to maximum of these three. So this is the graph of gx. Now we have to find the area enclosed by y equal to gx, x-axis and the lines x equal to plus minus 2. So we can write area equal to, from minus 2 to minus 1 the graph is x square into dx, and from minus 1 to 0 the graph is minus x into dx, and from 0 to 1 the graph is x into dx, and from 1 to 2 the graph is again x square into dx. So this equal to, integrating, we have x cube upon 3 from minus 2 to minus 1 plus integral of minus x, that is minus x square upon 2, that is from minus 1 to 0, plus x square upon 2 from 0 to 1, and again x cube upon 3 from 1 to 2. So this is equal to minus 1 upon 3 minus, putting minus 2 will give us plus 8 upon 3. Similarly again we will get 1 upon 2, and here also 1 upon 2 plus 8 upon 3 minus 1 upon 3. So this is equal to 7 by 3 into 2, that is 14 by 3 plus 1, that is equal to 17 upon 3 square units. So from the given options we can see that option number 2 is the correct answer.